Welcome to AT Math Academy. Problem for today is matrices, and in my earlier videos I have shown you finding the determinant and inverses of a 3 by 3 matrix, and let me show how to find out the inverse of a 2 by 2 matrix. So let's start by taking an example of a 2 by 2 matrix: 5, 9, 3 and minus 8. So this is indicated as 2 rows. This is 2 rows and 2 columns. So it has 4 elements, which is 5 and 9 and 3 and minus 8 and 2 of rows, and the column would be 5 and 3 and 9 and minus 8 in the columns. So let's start by finding the determinant of a matrix. So let's first indicate this matrix with A, and I'm going to write down the formula for finding the A inverse as e to the power minus 1, which is the inverse of A is indicated by e to the power minus 1, and the formula for that is 1 by determinant of A multiplied with interchanging the elements here. So suppose the standard elements would be A, B and C and D in the 2 by 2 matrix. So 1 by determinant of A would be AD minus BC, multiplying the diagonal elements and subtracting, and it should be multiplied again with interchanged of A and D. So D goes to the top position and A gets to the bottom, and I am placing a negative sign for these two elements of B and C, minus B and minus C. So this is how you do it for the formula for the A inverse. 1 by determinant of A, and determinant can be found out by multiplying the diagonal elements AD and BC and subtracting them, AD minus BC, and this entire 1 by determinant of A should be multiplied with this, where we are interchanging the one of the diagonal elements A and D gets interchanged, and the other diagonal elements remain same, but the sign gets changed. We are just changing the positive numbers becomes negative, and if there are negative numbers they become the positive. So let's start for our example here: 5, 9, 3 and minus 8. So 5, 9, 3 and minus 8. For finding the determinant of this matrix, we need to multiply 5 with minus 8 and subtract 9, product of 9 and 3. So for A I have the values of 5, and for B it's 9, and for C it is 3, for D it is minus 8. So A times D minus B times C, 5 times minus 8 minus 9 times 3, which is minus 40 minus 27, which is minus 67. This is the determinant, and so A inverse is nothing but 1 by determinant, which is minus 67, multiplied with the product of this one, interchanging the D and A. So I am interchanging my minus 8 and 5, and I need to apply the negative sign for B and C here. So my B is 9 and my C is 3, so I'm applying negative sign of minus 9 and minus 3. So this is how you write the values D and minus B, minus C and A. So here I'll be left over with minus 1 by 67 and minus 8, minus 9, minus 3 and 5. So which is nothing but minus 8 by minus 67 and minus 9 by minus 67, minus 3 by minus 67, 5 by minus 67. So I can rewrite this as 8 by 67, 9 by 67, because negative and negative gets cancelled out, 3 by 67 minus 5 by 67. So this is my A inverse. So this is how you find out, and this is the total glimpse of the problem. So my given matrix, and I'm comparing it with the standard matrix ABCD and have written the values for A, B, C and D, and the determinant is AD minus BC. So I have multiplied this and got my determinant, and this has to be multiplied with this matrix here, interchanging A and D and applying the negative sign in front of B and C. So I interchanged my A and D, minus 8 and 5, and applied the negative sign for B and C, and I have multiplied it with 1 by determinant of A. And here is the resultant inverse matrix for a given 2 by 2 matrix. Hope you all like my video, and please subscribe to AT Math Academy. Thank you for taking time to watch this video, and enjoy doing math. Enjoy doing math at AT. Thank you.